Okay, so this is part three of our study on inverses and inverse functions. And basically, this part three is mainly a review of some of the concepts that we've discussed. In part one, you may recall we had this function f of x, which is 4x minus 1, and we saw that the inverse of that function is x plus 1 divided by 4. So remember, here you're multiplying by 4 and then subtracting 1, so the inverse undoes what this does. So remember that subtracting 1, we add 1, and then multiplying by 4, the inverse will divide by 4. And remember the notation. So this is f of x, then we'll call this f inverse of x. So remember that exponent, don't think of this as a true exponent. This means f inverse. It does not mean f to the negative 1 power. Okay? All right. Now, we saw, if you go back to part one, we saw that if we use a t-table right here, so I'm going to go ahead and kind of cover this part up. So we saw that when x is 0, we get 4 times 0 minus 1, we get negative 1, and so on. All right. So these points, these ordered pairs, are solutions to this function. Same thing here. So these ordered pairs, so for example, if x is negative 1 and I substitute negative 1, negative 1 plus 1 is 0, 0 divided by 4 is 0. If x is 3, 3 plus 1 is 4, 4 divided by 4 is 1. So that's how we're getting these y values here. All right, so remember, f of x means the same thing as y. F inverse of x will mean the same thing as y. Okay? All right, now here's what I want to remind you about this before we go on. So you see the t-table here, right? Okay. So remember what this means right here. So f of, let's say, 1. F of 1. So f of 1 means I go to my function. Where we see the variable, I substitute 1, right? So that'll be 4 times 1 minus 1, which is 4 minus 1, which is 3. Y'all agree? In fact, that's how we did this, right? F of 1, I went here, and that's how I got 3. Same thing here. F of, let's say, negative 1. F of negative 1. So I go to my function, and where we see the variable x, I substitute negative 1. So I get 4 times negative 1 minus 1, negative 4 minus 1, which is negative 5, and that's what I have here. But again, when we filled in this t-table, we actually went in and we substituted the value of x into here, and we found the y value. Okay? Same idea here. So I want you to see this part. So here I used f of 1. I used f of negative 1 because that was my function. All right, over here, my function is called f inverse. So I'm going to say f inverse of, let's say, negative 1. All right, so notice the difference between these two. So this says I go to my function f. This says I go to my function f inverse. And wherever we see the variable x, I substitute negative 1. All right, so I get negative 1 plus 1 divided by 4, which is 0, divided by 4, which is 0. And that's how I got this, right? So f inverse, let's say, of 7. I go to my function where we see the variable x, I substitute 7. So that will be 7 plus 1 divided by 4, which is 8, divided by 4, which is 2, and that's how I got 2. Okay? All right, now, there's a reason why I'm doing this. We're going to come back to that in a little while. Okay? All right, so let's go ahead now and look at this example. All right, so this would be number 1. So number 1, algebraically determine the inverse of each of the following. All right, so you want to do this algebraically. All right, so you got to show those steps. So 1a, so here's my function, f of x, and that's equal to 2x minus 3 divided by 5, right? All right. So remember, step 1 is to replace f of x with y. So I get y equals 2x minus 3 divided by 5. So that was your step 1. Step 2 is to interchange the variables. So x equal 2y minus 3 divided by 5. All right, so that's where we have to interchange the variables. Okay. And then step 3, or the next step, would be to solve for y. So we're going to go ahead and solve for y. So when I solve for y, let's go ahead and get rid of this denominator. So multiply both sides by 5. And so when I do that, I get 5x equals 2y minus 3 divided by 5. So basically, I'm going to multiply by 5, right? So I multiply both sides by 5. So I rewrote this over, and I said times 5 times 5. These 5's divide out. So I get 5x equals 2y minus 3. All right, the next step is, remember, is trying to get y by itself. So the next step is to add 3 to both sides. So I get 5x plus 3, not 8x, because that's not a 3x, that's 3. So 5x plus 3 is equal to 2y, and then finally divide by 2, and there's your answer. So I get 5x plus 3 divided by 2 equals y. And then finally, you're going to replace y with what you're trying to find. So if this is your function, f of x, okay, right here, then its inverse is this. So that'll be 5x plus 3 divided by 2. All right, so that's 1a. Okay, you can do the same thing with 1b. All right, so here's 1b. So 1b, we have, let me go back and find it. So 1b, here's our function g of x right here. So I'm going to go ahead and rewrite this. So g of x is going to equal 2x divided by 7 plus 3. And so I'm trying to find g inverse of x. That's what I'm trying to find. Okay? All right, so first thing you do, just like we've been doing, is replace g of x with y. So I get y equals 2x divided by 7 plus 3. All right. Then the next thing I'm going to do is interchange the variables. So x equal 2y divided by 7 plus 3, right? And remember, when we graph these, so remember we're interchanging the variables. So basically y becomes x, x becomes y. So remember, these two inverses, these two functions that are inverse of each other are symmetrical about the line y equals x. Remember that? So if I go quickly and look at this example right here, so remember these two functions will be symmetrical about the line y equals x. All right, so that's one of the reasons why we say replace y with x and x with y, because y equals x, x equals y. We interchange the variable, so they're symmetrical about the line y equals x. Okay, so now we're going to solve for y. So what I'm going to do, I'm going to go ahead and rewrite this over. And here's the way I'm going to do this. Okay, so what I'm going to do first is don't deal with this fraction yet. Let's go ahead and subtract 3 first, make things a lot easier for us. So I'm going to subtract 3 from both sides. So I get x minus 3 equal 2y divided by 7. Now let's go ahead and deal with this part. So right now I'm dividing by 7. So to do the opposite, I'm going to multiply both sides by 7. So I'm 7. Don't forget to put this in parentheses. Times 7. Leave it like this. Don't distribute. You can if you want to, but leave it like that. I would just leave it like that. All right, and these 7's divide out. So I get 7 times x minus 3 is equal to 2y. And then finally get y by itself. I'm going to divide both sides by 2. And so I get y equals 7 times x minus 3 divided by 2. And that's your inverse. So that's g inverse. So g inverse will be 7 times x minus 3 divided by 2. Okay? All right, so it kind of makes sense because remember, here's my function. So my function g takes the value of x, multiplies it by 2, then divides by 7, then adds 3. The inverse does the opposite. So it takes the value of x, subtracts 3, okay, then multiplies it by 7, and then divides by 2. All right? Okay, so that was 1b. Okay, so let's look at 2. All right, so 2 says find the inverse of each of the, find the inverse of each of the relations. Now, your relation here is a finite set, and both of those are functions. So they're functions, and you want to find the inverse of that. So let's go back to the problem we had earlier, okay? I want you to notice something. So y'all remember that these two functions are inverse of each other. All right, so look at the t-table. And we had a discussion in part 1 when we did this. 0, -1, 1, 3, -1, -5, 2, 7, and -2, 9, right? -2, -9. So that's the t-table for this function. What do you notice about the t-table for the inverse? What do you notice about them? Well, the x becomes what? These x values become the y values, and these y values became the x values. So basically, when we had the discussion, we said that if -0, -1 was on f of x, then -1, 0 would be on the inverse. So you interchange the coordinates. Remember that? So 1, 3 became what? 3, 1. -1, -5 becomes what? -5, -1, and so on. Okay? All right, so we're going to use that idea with number 2. So let's look at number 2. So number 2, you have in part A, you have this. So let me go ahead and rewrite this. 1, -3, -2, 3, 5, 1, and 6, 4, right? Okay, so you're going to say the inverse is going to be this set. So the inverse is, and remember what we did, we just interchange them. So 1, -3 on the inverse becomes -3, 1. -2, 3 becomes 3, -2. 5, 1 becomes 1, 5 on the inverse. And then 6, 4 becomes 4, 6. And that's all you do. So that's the answer. So the inverse of this is this. Okay, so remember, all you're doing is just interchanging the coordinates. Okay, that's all you're doing. All right, 2b. All right, 2b, you have the same thing. So you're just going to do what we just did. -5, 7, -6, -8, 1, -2, 10, 3. And so the inverse is, all right, so you should be able to do that now. So that's going to be the set that has these four points. 7, -5, right? And then -6, -8. On the inverse, it becomes -8, -6, -2, 1, and then finally 3, 10. Okay? All right, so that's 2. All right. Now, let's look at 3. All right, in 3, you have this. It says, suppose that f is the following relation. So it has these 4 points. It has a point 3, 2, the point -2, 1, the point 6, 3, and the point 7, -3. And you want to find each of the following. So we want to find f of 6, you want to find f inverse of -3, you want to find f of 3, you want to find f inverse of 3. Okay? All right. Now, don't let that part confuse you, because we talked about that here. All right, so let's think about this. So remember, we had this t-table, right? So we had the set of ordered pairs right here. So that this t-table is just this right here. I mean, it's not the same points, but that's the idea. So when to find 1 here, so when the x value is 1, what was the y value? 3, right? When the x value is -1, what was the y value? -5. I mean, obviously we got that from here, but that was my set of ordered pairs that I used. But I want you to notice here, when I say f of 1, that means, remember what that means? That means what is the y value when x is what? 1. So when x is 1, what's the y value? 2. Okay? Same thing here. This says, what's the y value when x is what? -1. Well, when x is -1, what was the y value? 0, right? Okay? But what I want you to notice is this. I could go here and do that. So look carefully. So if all you have is just this, you can find this right here. So I'm going to go ahead and rewrite this over. All right, so all I did was I rewrote this part right here, and I put that here. All right, so here's my question. All right, listen carefully. What is f of, let's say, 2? What are you going to tell me? So f of 2. So look, without looking at this, what's f of 2? So remember, f of 2 means what is the y value when x is 2, right? Well, when x is 2, what's the y value? 7. So f of 2 is 7. Okay? No big deal. Now, what if I asked you this? What is f inverse of, let's say, 3? What is f inverse of 3? Oh, well, you may say, well, I don't see a 3 here in the x column. Well, you don't. Because I'm not asking what f of 3 is. See? I'm asking what f inverse of 3 is. Okay, so I'm not asking this. So I'm not asking what f of 3 is. I'm asking what f inverse of 3 is. Okay? Now, if I wanted to, I can find f of 3. Okay? Look, f of 3. Go back to your function. When x is 3, what's my y value? Well, my y value is 4 times 3, which is 12, and then 12 minus 1, which is, let me go ahead and write it, 4 times 3 minus 1, so that's 12 minus 1, which is 11, right? So f of 3 is 11. But what is f inverse of 3? That's the question. Well, remember when we did this, let's go back here. When I found the inverse, do y'all see that all I did was interchange the coordinates? That's all I did. So if I want to find f inverse of -1, I don't have to look at this at all. I just have to look at this. So the inverse is just you're interchanging the coordinates. So now what you're going to do to find f inverse, I mean, this is f of x, right? So f inverse is you're interchanging the coordinates. So you can look for it. See, this is inverse. This is f. So you can look at the coordinate that's in the y column. All right. So f inverse of -1 is going to be what? 0. Because remember what the inverse does. The inverse undoes what your function did. All right. So I want to undo this -1. So I want to go back to what the value was originally. So I went from -1 to 0. Okay. I went from negative. I'm sorry, this is 7. So I went from 7 to what? 2. That's where I got the 2. All right. So basically what I want you to think of is this. So f inverse of 3, without even doing that other column, what's f inverse of 3? F inverse of 3, this is f of x, and f inverse of 3 will be what? 1. Okay, what is f inverse of 11? F inverse of 11 will be what? 3. Kind of makes sense because f of 3 is what? 11, so the inverse goes back. All right, see what's happening? So f inverse of 11 is 3. Here's f of 3. All right, so f of 3 is 11. The inverse undoes what just happened. So the inverse takes 11 and brings it back to what? 3. Okay, that's what's happening. So the inverse takes 11, brings it back to 3. That's what we just found. All right, so here the f of 2 is 7, right? So f of 2 is 7. So what if I wanted to find f inverse of -7? So the inverse brings it back. So what would be f inverse of -7? It will be 2. And you don't, yeah, you see that here, right here. See, right here. You bring it back. All right. Okay, and then if we go back to this function, see f inverse of 7 right here was what? 2. All right. So here's what I want you to think about. All right. Now listen carefully. Suppose g of x, g of 6 is -5. All right. You don't know what the function is. This is all I'm telling you. What is g inverse of -5 then? Remember what the inverse does. The inverse undoes what just happened. So whatever g is, it took 6 and brought it and gave me a value of what? -5. The inverse brings it back. So the inverse of -5 then would have to be what? 6. That's right. So again, let's find h of 7 is, let's say, 2. What is h inverse of 7 then? What's h inverse of 7? I'm sorry, h inverse of 2, excuse me. So if h of 7 is 2, then the inverse takes it back. So what's h inverse of 2? 7. All right, so that's what inverses do. All right, so if you have your function and you have the inverse undoes what your function did. All right, so I'm going to ask you this. Okay, hopefully that should help you with the next question. So here's the next question, number 3. All right, so here's your function f right here. So your function f has 4 points on it. What is f of 6? All right, remember f of 6 means this. So let me go ahead and write this over so I can write some things down. So here's f, so f is this. It's the relation that has these 4 points, 3, 2, negative 2, 1, 6, 3, and then 7, negative 3, okay? All right, so part A is f of 6. So remember what that means. That means what is the y value when x is 6? Okay. All right, well, there's your function f, right? Okay, so f. These two match. So go and you find what, when x is 6, what's the y value? So what's my y value? 3. All right, so just real quickly, what do you think f of 3 is? Be careful, that's f, not inverse. So f of 3 is what? 2. What's f of negative 2? Quickly, what's f of negative 2? F of negative 2 is what? 1. What's f of 7? What's f of 7 real quick? F of 7 is what? Negative 3. All right? And it's all I can do because you only had 4 points, right? Okay, now, let's look at B. B says this. What is f inverse of negative 3? F inverse of negative 3. Right here, negative 3. All right, now be careful. Be careful. You might say, well, I don't see a negative 3 here. Well, that's because you're looking for your x coordinate. Okay, remember this is f. I'm looking for what? The inverse. Okay, so what you got to do is remember what the inverse does. The inverse, what f did was it took these x coordinates and gave you a y coordinate, right? The inverse goes the other way around. The inverse goes the other way around. All right, so you want to look for where your output was negative 3. So what do you see your output being negative 3? Right here. So the f inverse of negative 3 brings it back. See, the inverse brings this thing back. It undoes it. So you're looking for the end result. So this is going to be your end result. My end result's negative 3. So f inverse of negative 3 then is going to be what? 7. All right. Real quickly, what do you think f inverse of 1 is then? All right, f inverse of 1. Well, f inverse of 1 is what? Negative 2. Okay, kind of makes sense because the function took negative 2, gave me this output. The inverse brings it back. So f inverse of 1 will give me what? Negative 2. All right, okay, C. C, you want to find f of 3. All right, we already did that. F of 3 was what? 2, right? Okay, but what's D? Think about D. What's f inverse of 3? So what you want to be careful here is don't get these two confused. All right, some students, they'll say f inverse of 3 is 2 because they're forgetting that this is your function f. So f of 3 is what? 2. F of negative 2 is what? 1. F of 6 is what? 3. F of 7 is negative 3. But we're going to do the inverse. The inverse goes the other way around. Okay, so f inverse of 3, you look for your output being 3, so the inverse is 6. Now, all that being said, okay, we're done with 3, but all that being said is this. If this is f, could you have used this idea in 2? See, this is your inverse, right? This is your inverse, right? Could you have used that idea in 2 to rewrite this, to rewrite f inverse? Okay, look, I'm writing this right here. F inverse equals. If this is your function f and has those 4 points, then what does the inverse become? the inverse becomes 3, 2 becomes what? 2, 3. Negative 2, 1 becomes what? 1, negative 2. 6, 3 becomes what? 3, 6. And then 7, negative 3 becomes negative 3, 7. And so if you wanted to find f inverse of 2 now, see that's your inverse now, so f inverse of 2 is now what? 3. F inverse of 1 is what? Negative 2. F inverse of 3 is what? 6. And f inverse of negative 3 is what? 7. All right, so see, if you need to, then go ahead and rewrite the inverse of that function, and now you can answer all these questions that deal with inverses based on this. Okay? All right, so it is a concept that's a little hard to understand at first, but once you study the idea of inverses more, it becomes a little bit understandable. Okay, and then finally, in number 4, we want to review how to graph the inverse of negative 2x plus 3. All right, so the way to do that is to, first of all, let's graph negative 2x plus 3. All right, and then without even, listen carefully, without even finding the inverse like we did here, we're just going to use the set of ordered pairs to help us graph the inverse. All right, so in other words, let me go ahead and find my graph paper. Okay, so we're going to graph the inverse of this function by, first of all, graphing the function. Okay, all right, so we're going to graph the function. Let me go ahead and do that here. So here's g of x, which is negative 2x plus 3, and I'm going to use the t-table. All right, so if x is, I'm going to use the table x and y. And so if x is, let's say, 0, I get negative 2 times 0 is 0, 0 plus 3 is 3. If x is 1, negative 2 times 1 is negative 2, negative 2 plus 3 is 1. If x is negative 1, let's say, I get negative 2 times negative 1 is a positive 2, 2 plus 3 is 5. Okay, and let's do one more. If x is, let's say, 2, I get negative 2 times 2 is a negative 4. Negative 4 plus 3 is a negative 1. Okay, so I'm going to put those points in the coordinate grid. All right, so I have 0, 3. I have 1, 1. I have negative 1, 5. And I have 2, negative 1. Okay, and I'm going to use my ruler to draw the graph. And so when I do that, I'm going to get, let's see. Okay, so I'm going to get this graph right here. Okay, all right, so this is, we call this what, g of x? Yep, g of x. So that's g of x. So g of x was equal to negative 2x plus 3. Okay? All right, now I want to graph the inverse. All right, so the inverse. Now before I do that, let's go ahead and graph y equals x, because remember, inverses are symmetrical about the line y equals x, right? So y equals x is easy to graph, right? Okay, y equal x is easy to graph because that says if x is 1, what's y? 1. If x is 2, what's y? 2. So notice that the x and y values are the same. So the x and y values are the same when you look, if you look at the first and third quadrants, when the points are identical, when the coordinates are the same. So 2, 2, 3, 3, 4, 4, 5, 5, and so on, right? 0, 0, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. So that is y equal x. So when I graph that, so this is a line y equal x. All right, so that's what I just graphed, y equal x. So that's my line of symmetry. So g of x, when I graph the inverse, is going to be symmetrical about that line. And basically all you do is this. If you know, all right, think about what we just discussed. If you know that 0, 3 is on g of x, then what point is on the inverse? What point would be on the inverse? Well, the point 3, 0, right? So let's plot the point 3, 0. So if this is 0, 3, then we're going to plot the point 3, 0 right here. All right, and remember we talked about this as well in one of our previous lessons. So if I, and I'm not going to draw this because I don't want to mess up the graph, but we had this discussion. See this segment? If you were to draw a segment here, that segment would be perpendicular to this line y equal x, right? And this distance, so the distance of the point to the line of symmetry is the same as this distance here. All right. Okay, now let's go to the other one. 1, 1 on the inverse becomes what? 1, 1. Well, that's this right here. All right, that's this. Okay. -1, -1, 5 becomes what point of the inverse? 5, -1. So let's plot that point. 5, -1. 5, -1's right here. Okay. And then finally, 2, -1 becomes what point? -1, 2, right? So let's plot the point -1, 2. So -1, 2 is right here. And then take your ruler and then connect those points. And what I'm about to do is going to be the inverse. So this is g inverse of x. That's your inverse. So these two graphs are symmetrical about that line. So notice this part. I just want you to see this. This part, when I reflect it about that line, becomes this part. See that? So this becomes this. When you reflect that about the line y equal x, becomes that. All right. This, when you reflect about the line y equal x, becomes that. You see it? This goes to this, and this goes to this. Okay? All right, so that's what you have to do there. So that's number 4. Now, one more problem. Okay, so finally, what I want to do now is look at this problem here, right here. And so let's suppose that this is my function f of x, all right? So let's say this is f of x. What I want you to do is to graph the inverse. All right, let's graph the inverse. All right, so now notice this is an easy one to graph because I kind of denoted some points here, right? And so notice that the graph is made up of segments, so it's easy to graph. And so we're going to use the idea that we just did here. So basically meaning that if 0, 3 is on your function, then 3, 0 is going to be the inverse. If 1, 1's on your function, then 1, 1's going to be the inverse. If -1, 3 is on your function, then, I'm sorry, 5, then 5, -1 will be on your inverse. We're going to use that idea. So we're going to use that idea here. So see this point here? That's the point right here. So that's the point -9, -7. So -9, -7 becomes the point -7, -9. So that is here, okay? Right here. See this point -7, -2? That becomes the point -2, -7. So that is here, okay? See this point right here? That's -3, 3. So that becomes a point 3, -3. All right? And then finally, see this point right here? That's the point 4, 6. It becomes the point 6, 4 right here. And so basically all you're going to do is connect those points with segments. And so you're going to do this, and then you're going to do this, and then you're going to do this. And then this is the inverse. That's the inverse of f. And so if you were to graph the line y equal x, 0, 0, 1, 1, 2, 2, -1, -1, -2, -2, and so on, you will see that those two graphs are symmetrical about that line, y equals x. Let me do a little bit more. Okay, and let me do a little bit more here. All right, you see how this graph is symmetrical about that line? Okay. All right, and then remember the idea of that distance. So I went from here to here for the inverse. So notice that this is same as that distance. Over here, this distance right here, same as that distance. Notice that this, if you were to draw that segment, it would be perpendicular to the line y equals x. Same thing here. Okay. This distance, same as that distance, and if you were to draw that line connecting those 2 points, will be perpendicular to that segment. And so that's how you do this. So it's not that difficult. It's fairly simple once you continue working with that concept of inverse and inverse functions. All right, so that's the end of part 3.